Aloha and welcome to the 23rd installment of the Pythagorean Order of Death podcast, or the POD podcast. This is the 23rd installment, and as always, I am your host, Jonathan Barlow G. And in this 23rd installment of the podcast, I'm going to be answering questions again from a robot from Chat-GPT. This is going to be the second installment of that sort of arrangement where I ask the Chat-GPT robot to ask me 20 questions on a certain subject. So far, it's a book or two that I've loaded into it. This particular book is my T4 book. And so the questions that the ChatGPT robot gave me were on time travel. So this is going to be an interesting discussion between myself and the robot, rather one-sided though. The first on time travel between myself and ChatGPT. And without further ado, let's get right down to the nuts and bolts of it. Jonathan, in your introduction, you describe time as the standard arrow along a seventh spatial direction. Can you unpack that metaphor and tell us how it reframes our usual 4D space-time picture? It isn't a metaphor. In the introduction, the standard arrow of entropy, where all matter gradually breaks down into energy, is described as being the usual definition for time. I add to this the definition of time as motion or change of otherwise static 3D matter energy from one temporal event to the next. In space-time, there are the six standard directions: up, down, left, right, front, back, and the additional singular direction of time, past to future. Thus, it can be said that there are seven directions of motion for the local universe, including six directions within the local universe, and one direction that combines all these motions into universal expansion. You propose that entropy defines our universal Hubble constant in the time direction. How does this reinterpretation affect our understanding of cosmic expansion? It doesn't. The effect of universal expansion at the relatively stable rate known as the Hubble constant occurs as a direct result of entropy occurring at a quantum scale, universally. This can be demonstrated by the conservation of angular momentum due to the force of gravity. Inside galaxies, gravity from the core black hole creates and draws stars inward in a usually spiral plane, and from these stars creates and draws in planets to usually elliptical orbits, and so forth, eventually creating life. However, outside these galaxies, in the depths of the vast voids beyond the thinly dispersed intergalactic plasma filaments, gravity, and thus time, does not function in the same way. Therefore, inside galaxies, gravity conserves otherwise universally ubiquitous expansion of entropy. So, the more galaxies shrink within, the more the empty spaces around them must grow and expand. In part 2, you outline three possible cosmic geometries: closed, flat, and open, and their implications for time travel. Which scenario do you find most plausible, and why? As stated in the paper, the local universe is unlikely to be ubiquitously uniform across its entire expanse, and so there should be regions inside of spacetime with closed, flat, and open geometries. Another way to think of closed, flat, and open geometries is as spherical, Euclidean, or hyperbolic geometries. If the local universe contains a certain amount of mass greater than a certain critical mass variable, then its overall shape will be the same as a globe, and thus its surface will be a closed area of no less than 8 total triangles, each comprised of 3 angles, each angle of 90 degrees. If the local universe's sum of all mass, combined matter energy, is exactly equal to the critical mass variable, then the shape of spacetime will be flat, or a Euclidean plane space. If the local universe's mass is less than critical mass, it will assume a hyperbolic curved shape, such as the saddle shape of a sheet on a toroidal manifold. The reality is that spacetime may most proximately resemble a 4D sphere, while hyperspace surrounds it in a hyperbolic toroid shape, but the mass within this sphere is unevenly distributed, such that inside the local universe, there are different places that, at different times, exhibit all these traits. Moons, planets, stars, and black holes may exhibit a closed geometry and a spherical surface. Spiral galactic accretion disks of stars gathering around and toward a core black hole are clearly planar or flat, and electromagnetic fields surrounding planets, stars, black holes, and even spiral galaxies themselves, although usually invisible to the naked eye, are toroid shaped. Therefore, whatever overall shape the local universe may take, it already exhibits all of these traits for geometric pattern within itself. More to the point, time behaves differently in each of these different circumstances. In a closed spherical space-time, the local universe will expand until it reaches a certain diameter and circumference, and then it will collapse and shrink back down in a big crunch, potentially reversing entropic time at that point. In a flat Euclidean space-time, the local universe will expand until it reaches the point of critical mass, and then simply cease progressing in this manner, ending time as motion in a heat death. In a hyperbolic toroidal hyperspace surrounding the local universe at faster than light speeds, space-time will be pulled outward to expand into this energetic vacuum forever. In the presence of closed spherical geometries for space-time, there may arise closed time-like curves. Just like on Earth, there are time zones. Your temporal key and lock analogy elegantly captures inertia and adaptation between epochs. How might this shape the engineering design of a future time machine vessel? The analogy of the temporal lock and key refers to the key of the individual and the lock of their temporal environment. When one leaves one's temporal environment, the lock closes and would require a different key to reopen. The benefit of this model is that it can provide the real-world example of time traveling in the form of a passenger on an airplane flying from one time zone to another on Earth's surface. The result of this effect on the person's biology is called jet lag and corresponds to the time it takes an individual's temporal key to adapt to their new temporally locked environment. The manner this lock and key concept factors into the physical designs for a real-world time machine capable of surpassing relativistic light speed is in that the vessel is meant to shield the passenger from the inertial effects of acceleration and deceleration, in much the same way a decompression chamber helps one alleviate the bends if one changes pressure deep underwater too rapidly. To sustain the hull's structural integrity, while simultaneously maintaining interior cabin pressure, remains one of the mysteries about time travel using such a vessel. I have, of course, made my own UFO schematic designs, though the materials of which such a craft could actually be made remain unknown as of yet, even to me. When discussing wormholes in Part 3, you differentiate stationary gravitational versus moving electromagnetic types. Which do you see as the more viable path experimentally, and what exotic matter or fields would they require? A stationary gravitational singularity is known as a black hole, and a moving electromagnetic singularity is called a wormhole. The reason the black hole is called stationary and the wormhole considered moving is due to the fact that the black hole's entrance, its event horizon, always leads to its core, the gravitational singularity or singularities at its center, while a wormhole's entrance usually leads to a random and unpredictable location in space-time. For example, a stationary singularity that forms uh, from a stellar supernova can have spin, rotation, revolution, and polar precession, and still remain locked in its original location, thus forming a black hole. An apparently random gamma ray burst in deep space that is paired with another simultaneous burst somewhere else in local spacetime is considered a wormhole between these 2 points. Because it is predicted that any object or pulsed signal can travel from the entrance of a wormhole to its exit somewhere vastly distant at a nearly instantaneous speed, this phenomenon is also called a temporal singularity. Such a temporal singularity also occurs at a much smaller scale, almost constantly, as the so-called Compton effect. When a photon strikes an orbiting electron for the duration of the impact, the position and trajectory of the electron can be measured, but the photon cannot. Then, afterwards, this situation reverses again. Although this event usually takes little more than a Planck time to transpire, it is still considered quantum tunneling, as the photon disappears and then seems to suddenly reappear in a different location, bouncing off the electron orbit at a trajectory altered by its impact. The Temporal Law of Paradoxes, Part 5, surveys Novikov's self-consistency and Deutsch's many worlds. Do you favor one resolution over the other, or is there room for a hybrid? Novikov's self-consistency principle and Hawking's chronological protection conjecture limit the extent to which the entropy from any parallel or branching timelines would be able to influence the mainstream timeline to a quantum size scale. On the far opposite end of the spectrum, The full extent of Deutsch's many worlds hypothesis is that every time a choice is made, a whole entire new universe is created. The obvious reality is neither of these. Just as we live in a local universe that has within it black holes that may contain within them smaller baby universes, it is likely our own local universe is a baby universe inside of a black hole inside a much larger parent cosmos. Just as a single black hole may contain multiple gravitational singularities at its core, and thus perhaps foster multiple baby universes, so too our own local universe may be only one of an unknown sum of other parallel dimensional neighboring baby universes to exist within the larger parent cosmic black hole. Indeed, string theory proposes that as many as 11 local dimensions may exist, even though in spacetime only four of these expanded. This still leaves behind enough unexpanded dimensions to comprise two neighboring universes, each of three dimensions, and all sharing the common direction of past to future time. Of course, there may be even more non-local dimensions, and thus more neighboring universes to our own as well, of equal size, mass, velocity, even laws of physics. We do not yet know because we have no maths, let alone instruments, capable of detecting beyond the boundaries of our own local universe. Thus, a physical multiverse of baby universes inside the local universe, inside the parent cosmos, definitely exists. However, a probabilistic multiverse of parallel or branching timelines is still apparently unlikely. Your historical introduction spans Sumerian Apkallu, Enoch's visions, to Epimenides' 57-year sleep. What drove you to blend mythic narratives with modern physics in this way? Myth is the context in which the mentions of time travel or time dilation have occurred. The solution to Fermi's paradox of where are all the time travelers is simple if you do not entirely discount myth as exclusively fictional. There are almost as many examples of time dilation in the myths of all the world's different cultures as of the world flood. The tales of Adapa, the Apkallu, on trial on Nibiru, of Ryumi Kukudmi in the court of Vishnu, and of the antediluvian patriarch Enoch and his dreams of how the original calendar could work. These all provide ancient examples from various cultures of the concept of time dilation and temporal variance. This idea of time as variant, different in different places, rather than ubiquitously, universally absolute, always identical everywhere, is often cited as distinguishing the uncertainty and relativity of space-time imagined by Einstein and subsequent schools of QM, as apart from the prior puristic approach of unbreakable and constant universal laws imagined by Newton. Nevertheless, the myths demonstrate this issue was already being addressed in various cultures during the Bronze Age BC. These accounts, whether historical facts or, as is far more likely, not, are evidence of thought experiments being done by earlier people to unravel the idea of time. To ignore and avoid this evidence would be negligent, and so I have included it here alongside the purely physical principles involved in modern notions of time travel. In T1, you map a 1D timeline onto a Mobius strip on a sphere. Could you walk us through how that visualization leads to the 2D brane concept? In T1 basic geometry, I describe a closed time-like curve by comparing it to a Mobius strip or sideways figure 8, that is the lemniscate symbol of infinity, as a single loop with a single twist. To expand this unilinear lemniscate into a two-dimensional brane, that is, to expand the 1D string into a 2D ribbon, all that is required is to graph the same format for a CTC with one loop and one twist onto the surface of a sphere or other 3D object. In the case of a spherical geometry underlying the unwinding of the temporal ribbon, the single loop and twist manifest as twin poles on opposite sides of the sphere, one a clockwise rotating spiral, and the other seemingly rotating counterclockwise. The purpose of these sort of mental exercises or thought experiments is to allow the reader to become more versatile visualizing autocorrelating loops in 3 space in order to better understand how the separate fourth dimension of time itself may be peeled off the surface of 3D space and then manipulated independently, like the skin of an orange apart from the pulp of the fruit. T2's Hyperspace Alphabet introduces polytopes as letters of higher dimensional geometry. Which polytope do you consider the first word in a time travel equation? The particular polytopes referenced in the work are the regular polytopes from each dimension, of which there are a finite amount in total. These include, in 2D, the triangle, square, and pentagon. In 3D, the 5 platonic solids. In 4D, there are 6 regular polyhedra, and in all dimensions 5 and above, there are only 3 per each dimension: the simplex, the orthoplex, or cross polytope, and the cube polytope. In the context of using these as like letters in an alphabet, I suggest comparing them all to the 22-letter Hebrew alphabet, beginning with associating Aleph as the first letter with a vertex point, or zero-dimensional singularity. Next, an edge or line in 1D, followed by a circle or plane in 2D. Then follow the regular polygons in 2D, and then a 3D sphere introduces the 5 platonic solids in 3D, followed by a torus or hypersphere introducing the set of 6 regular polytopes in 4D, and finally the 3 regular polytopes in 5D and up round out the list, with the 5D orthoplex symbolized alphabetically as Tao. The work suggests that these shapes may be useful in more than simply a new alphabet of geometrical symbols, but eventually in constructing a solid, material bridge between our own local universe of 4 dimensions and our parent cosmos of 5D and beyond. Your wormhole mathematics in T4 invoke combined Riemann-de Sitter metrics. How do you reconcile the need for negative energy density with general relativity's energy conditions? The static de Sitter metric, representing the asymptotically curved conditions for spacetime found inside a black hole, combines with the super Riemann metric tensor, representing the expansion of the four elemental forces: gravity, photoelectromagnetism, fission, and fusion, as supersymmetries formed from the Lorentzian metric tensor proposed by Einstein for flat Minkowski space with added dimensionality. This combined Riemann-de Sitter metric replaces the Lorentzian metric for flat Minkowski space with the static de Sitter metric for asymptotically curved space-time. The intended meaning of this is that prior to the definition of the four elemental forces, prior to the differentiation of the four elemental forces, the conditions of the early universe were similar to those inside a modern black hole, and therefore it is asymptotically curved space-time and not flat Minkowski space that underlies the geometrical shapes and forms taken by the quanta of each elemental force. This model indicates the conditions of a negative energy density preceded this model indicates the conditions of a negative energy density preceded the separation of the four forces, but that following this, the energy conditions of general relativity began to govern instead. In T5, you sketch an imploding multiverse. How does that model address the Fermi paradox of where are all the time travelers? The imploding multiverse concept is based on the fact that most of the galaxies we can observe consist of stars that follow the main sequence for stellar lifespans, and that if the galaxy's distance from us in light years is greater than the age of its component stars along the main sequence for stellar lifespans, it is likely that this far-out galaxy we seem to see is actually already dead by the time its light reaches us. Thus, the further we look outward into deep space, the longer we are looking back in time toward the origins of the local universe as well. This effect accounts for the apparent young age of stars in the furthest observable galaxies. This model does not address the Fermi paradox, but instead depends on Einstein's notion of c as a fixed speed of light. The footnotes on ancient measurement systems, cubits, furlongs, Greek feet, are fascinating. How do these archaic units inform the modern dimensional constants you use? The so-called Greek foot divides 360,109 times into a single degree of arc polar circumference of the Earth. There are 360 such degrees in Earth's polar circumference of 129,639,240 Greek feet. The difference between the Greek foot of 30.861 centimeters and the modern imperial foot of 30.48 centimeters may account for the difference between the Earth's known polar circumference, around 40,007.863 kilometers, and the predicted circumference of the Earth calculated by Eratosthenes, who estimated the equator at 252,000 stadia. These ancient measurements of distance are incalculably important to the evolution of our measurement of time as well, such that we may measure the daylight or nighttime hours on the planet as occupying, on average, 64,819,620 Greek feet, or approximately 131,259,395.52 modern imperial feet around the equator. Also, since we now know Earth's rotational velocity to be around 1,037 miles per hour, or around 1,670 kilometers per hour, we can specify the exact duration of time it takes for Earth to rotate by 1 degree, or 1/360th of its circumference, as 4 minutes, or 1,444 minutes equals 24 hours, divided by 360 degrees. So we can say that Earth's surface at the equator is traveling 69 miles, or 111 kilometers, per every 4 minutes. Thus, we can say the Earth's rotational velocity at its equator is roughly 17.3 miles per minute, or approximately 27.84165 kilometers per minute. Such factors are immeasurably important in calculating jumps between one point in Earth's time and another, as the location of the planet is drastically different at every point along its timeline. Your tachyonic hyperspace field, as gravity's quantum, is bold. How might future experiments detect or harness these imaginary mass particles? The most commonly expected type of experiment to test tachyons is the so-called tachyonic anti-telephone, which can receive a signal before it is sent. Because this apparently violates chronological causality, it is unexpected to be successfully tested until we have developed a more thorough model of space-time that could allow for such causality loops or closed time-like curves. In quantum computing, a simulation of such a device has already been modeled successfully, sending a qubit across a quantum gap at apparently faster than light speed, such that it appeared to arrive before it left. This quantum computer model is still a long way from proving that tachyons carry the force of gravity, however. I suspect that a super collider or cyclotron ring, preferably built in outer space to minimize any potential damages from such an experiment, that could propel a stable ion to near relativistic speeds without colliding it into another particle to test the antimatter cascades, could also propel a superconductive monoatomic element to these velocities as well. I am confident the breakthrough in discovering tachyons will occur when observational equipment can measure the conditions of an electron without disturbing it by a photon, because by that point predictions will become more precise about what form of energy exists at measures of size scale smaller and faster than a single photon. I derived the theory of tachyons being the quantum of gravity from first principles. If a particle is repulsive in reverse chronology, then it will appear attractive in regular chronology. Thus, tachyons at FTL speeds move backwards in time and transmit the influence of gravity between quanta, even on the smallest now known size scales. You touch on chronology protection conjectures. Do you think Hawking's mechanism suffices, or might we need new temporal censorship principles? If anything, I think we should be searching for ways around such temporal censorship premises if we intend to arrive at the goal of time travel. For example, if all gravitational and entropic effects from a branching or neighboring timeline relative to the mainstream timeline are conserved to subatomic scales of size and influence, as Hawking proposed, this would seem to make it impossibly difficult to send a person from the mainstream timeline into the branching or neighboring timeline and return them. By setting the standards for successful time travel behind the bars of a chronology protection conjecture of any sort, it only sets back the progress that could be made if such mind traps were removed. For example, the many worlds interpretation that proposes timelines diverge due to wave function collapse from superposition, a condition of both and dependent on quantum scale uncertainty, into a standing wave state, a condition of either or, dependent in some case, or in some sense, on operant observer effect, is an accepted scientific theory, even though it is impossible in reality. Consider consider the divergence of two distinct timelines branching off from a single event. At first, the two different trajectories for the timelines would still appear to coincide, such that two separate universes would exist simultaneously, overlapping one another. However, as the timelines grow farther apart, more and more differences will begin to emerge between them. Since we cannot demonstrate this hypothesis physically, given the principle of entropy and the other laws of thermodynamics preventing this scenario, it seems unlikely to be the case in reality. That is, it is unlikely that every time a quantum wave function collapses, it spawns dimensionally parallel branching timelines that eventually reach the size of a whole self-contained universe. In short, a butterfly flapping its wings on one side of Earth may result in a tsunami on the other side of the planet, but the effect of quantum choice does not ultimately result in multiple parallel universes. So, as long as we hold up temporal censorship models like Hawking's chronology protection conjecture or Hugh Everett's many worlds interpretation, and expect reality to conform to them, the more we will be barking up the wrong tree and sabotaging our own capacity for finding true results. Ethically, you ask, if we can time travel, should we? What do you see as the top three societal risks if this technology ever arrives? It seems highly likely that, if we do develop functional time travel technology, by the time this will be possible, society, such as we know it now in modern times, will be just a fading memory from the future's past history. The sort of culture that will arise to replace modern social structures is difficult, but not impossible, to predict. In a better future, time travel will be discovered and used responsibly sooner than in a worse future. The true danger of time travel isn't to the fabric of society, but to the fabric of reality itself. Assuming time travel is even possible at all, such as speeding time up or slowing time down, freezing time, or running time in reverse, the ramifications to the known laws of physics of successfully inserting a temporal paradox into reality are catastrophic, and thus likely so would be the effects on the space-time continuum itself. You discuss causality loops and jinn of the first and second kinds. Can you give an example of how an information bootstrap paradox might manifest in a laboratory setting? In early 2020, Gordy Lisovic, head of the Laboratory of the Physics of Quantum Information Technology at the Moscow Institute of Physics and Technology, MIPT, used two superconducting qubits to functionally simulate, with 85% replicable accuracy, an event that occurs only once in the age of the universe, around 13.7 billion years, per 10 billion electrons being observed every second. This event is an electron's expected positional area compressing rather than expanding. In short, order out of chaos, rather than, as the universal law of entropy usually dictates, the other way around. In the context of the experiment, first an evolutionary program is run on two or more qubits, causing their locations in the system to scatter and decohere. Then a time reversal program alters the parameters of the system, causing it to reverse this scattering and decoherence process. Finally, the evolutionary program is run forward again as before, and in the 85% of successful cases, this causes the superconductive qubits to rearrange back into their original ground state for 1/10 billionth of a second before beginning to scatter and decohere again. Effectively, this research serves to demonstrate that, quoting Valery Vinokur from the Argonne National Laboratory, US, Schrodinger's equation is reversible. Mathematically, it means that under a certain transformation, called complex conjugation, the equation will describe a smeared electron localizing back into a small region of space over the same time period. Your notion of hypershapes, or metaforms in hyperspace, what mathematical tools do you propose to analyze their stability and topology? As hyperspace is 5D, so the metaforms inside it are fourth dimensional. Hyperspace is the 5D gravity field that surrounds our 4D spacetime continuum at faster than light speeds and that underlies our entire local universe at a subquantum size scale. Space is three-dimensional, and time is a fourth dimension added onto it. Therefore, the shadows of the 4D hypershapes, I call metaforms, cast into 3D appear as temporal cycles, most commonly seen as looped trajectories, like the orbits of electrons and planets, etc. While such orbital loops and temporal cycles are easily observable, the intuitive leap between seeing these as elliptical over time and seeing them as comprised of irregular polygons in 4 space may be less obvious. Consider Kepler's original model for the orbits of the planets, using the 5 Platonic solids nested, one inside another, to determine the distances between the planetary orbits. This obviously proved inferior to the later inverse square law formula for calculating the orbit of any planet given its mass, or vice versa. However, Kepler's first model, using the nested Platonic solids, remains a tantalizing artifact from his reasoning. If indeed the orbits could have been calculated by using the Platonic regular polyhedra, it would constitute a 1 in over a billion chance of naturally occurring in perfect harmony. So the shapes associated with the planetary orbits are not like the Platonic forms, but may be expressed as irregular angles, and these, over time, taken to comprise irregular polytopes in the 4-space dimension. For example, the 3D cube of a planet's volume becomes a 4D tesseract over time. In your speculative future trends you mention time travel board games and architectural diagrams. How do you envision public engagement with such educational tools? In virtual reality, it is possible to simulate non-Euclidean spaces that cannot otherwise exist. This includes not just modeling the hyperbolic geometries taken by light rays entering a black hole, but introducing 4 spatial dimensional shapes, and those of higher dimensions as well, as actual structures for architectural design. This means that VR programmers can design a hallway longer or shorter inside than it is on the outside. Assuming this environment accommodates a constant light speed, then light would take longer or shorter durations to travel this non-Euclidean hallway, and thus it would model a form of time tunnel or wormhole as well. Incorporating such chutes and ladders through time into a gaming system in order to educate people about these concepts is increasingly intuitive as such VR platforms continue to progress in detail and accessibility. Eventually, moving architectures with permeable walls founded on 4D and even 5D shapes will become possible to model inside of virtual reality, and these will ultimately be used in various new environments to perform tasks and solve problems we cannot even yet imagine. Introducing these as novel forms of entertainment is acceptable given their mostly harmless and potentially beneficial applications far outweigh their potential risk of causing damage of any kind. Given the vast speculative terrain you cover, from folklore to advanced tensor calculus, which part of which part of T4 are you most eager to see challenged or tested by peers? Most of the T4 material about time travel will remain speculative until well after I have shuffled off this mortal coil. I doubt peer review could apply to it yet. Everyone of any serious scientific credentials nowadays would likely scoff and consign it to the dustbin of history. The only particularly approachable idea of all of it may be the simple notion that tachyons are the quantum of gravity. But even this remains counterintuitive to modern cosmological theoreticians. If it does prove that tachyons are the quantum of gravity, then my own discovery of this fact, without making overuse of the language of QM itself to arrive at this conclusion, may be seen to threaten the authority of those quantum mechanics who devote themselves solely to this language and who specialize in obscure and cutting-edge fields. I would propose this threat would be perceived falsely, though. The language of modern QM is like the evolved hieroglyphics of the ancient Egyptians and is merely graffiti on the walls of Plato's cave. When one observes the outside world by sunlight, they may see all the wonders hinted at by the gropings and blind darkness of night laid bare. To such a one who sees by the light of day, the formulae and equations of theoreticians are incomprehensibly vague and pointless beside the realities they can plainly observe. For example, it is a matter of first principles that entropic order into chaos looks like negentropic chaos into order when viewed in reverse, and thus vice versa as well. Finally, Jonathan, if you could send a message back to yourself at the moment you first conceived T4, what advice or caution would you impart? In my earliest editions of T4, I included a section I have since omitted that tied this work into the same cohesive narrative all my other speculative works follow by presenting a story about Nikola Tesla involving the event in Tunguska, Russia on June 30th, 1908. At the time of these earliest editions, my intention was to provide continuity within the entirety of my works, and including this short, though fictionalized vignette, wove the T4 material into two film scripts I had written, one for a Texas Chainsaw Massacre movie, and the other a short film about a post-apocalyptic near future set in 2029. However, with the benefit of 15 years worth of hindsight, I find this passage about Tesla fits better into Episode 2, Act 3 of my ideas for a semi-autobiographical history/conspiracy theory franchise I call Coming of Age in the Apocalypse. I find more and more the more I age, the more important it is to separate fact from fiction. One of my earliest works, The Cult of Sleep and the Neo-Sethians, intentionally blended fact and fiction in a manner I have since found dangerous. basing a modern conspiracy theory on valid historical research in the first half, and then spinning off into ranting and raving about obviously fictional accounts of events involving real-life celebrities and political figures in the second half, while following a genre pioneered by schizophrenics, James Joyce's Finnegan's Wake, and acid heads, Robert Anton Wilson's Illuminatus trilogy, that I personally find enjoyable as blatant fiction, deluded many of my early fans into thinking I actually believe the entire contents of that work as truth myself, which I patently do not. Likewise, the reason I removed the Tesla Tunguska section from its original context in T4 and placed it instead in 2-3 of my film series idea is that fiction, fictional, and fictionalized or even speculative material should be kept distinct from facts, factual, accurate, and even honest material as strenuously as possible. I fear that placing the Tesla narrative as the original introduction to T4 may have left a stain of speculation on the T4 material I do not think it deserves. So those are 20 questions from a robot asking me about time travel from my work T4 theoretical time travel technology. Um, I hope everybody enjoyed that. It was a little dry, and I think I'm losing my voice a little bit here. I think I'm going a little hoarse, uh, which is uh, just fine as long as I keep drinking water, I suppose. But I'm gonna have to cut this short as a result of it, regardless. So before that happens, I'm just gonna say, have a great one. I'm glad everybody tuned in, and I hope everybody enjoyed the content. And I hope I'll catch you next time. And see you then. And peace. And I'm out. Peace.